Okay, so that section 5.1 took approximately 3 hours to upload using my Wi-Fi. So we're never going to do that again, okay? 52 minutes is entirely too long for a video. We're going to start nope, dyslexic moment. We're going to start 5.2, systems of linear equations in 3 variables. I'm definitely going to do this in chunks because ideally I can get the recording done at home. I can upload at home. It might be, more than one video per section, obviously, but it's just a little bit more convenient and a little bit easier. Plus, probably easier for y'all too to just kind of take it into 5-10 minute chunks instead of a whole hour. Like, that's insane. Okay, so 5.2 is systems of linear equations in 3 variables. So the way that our equations will look is ax plus by plus cz equals d. This is where all a, b, and c do not equal 0. Okay, your a can be 0, your b can be 0, your c can be 0, but all of them cannot equal 0. Okay, the solution set to these types of problems is going to be an ordered triple that satisfies all of the equations, right? Because we're going to have multiple equations. An ordered triple is x, y, z, x, comma, y, comma, z. So what we're used to seeing is an ordered pair, right? Pair meaning 2, and it was just x and y. Well, now we're actually also looking at the z-axis technically, but let's just consider it 3 variables. We're trying to figure out what the numerical value is for all 3 variables. Okay, so the way it's going to start out at first is it's going to ask you to test and see if an ordered triple is a solution set for the system of equations. So if you look at problem 1, I'm going to try to do the same thing I was doing last time. If I number the equations, we're going to number them with the dark blue, and then all of my work will be in purple, and I'm going to try to just, keep that straight. This problem 1, is asking me to show that -1 to -2 is a solution set, for this system of equations right here, okay? So what I'm going to do is I'm just going to go ahead and kind of write right here, like in a direction, like what we're doing. We're going to replace our x, y, and z values into equations. Okay, equations, plural, all of them, not just one, all of them. So let's go ahead. I can't write on this side of the screen. Let's go ahead and identify what these values are for these different variables. Because it's in an ordered pair, I know that it goes in alphabetical order, so it's x, y, z. Here, my x is going to be equal to -1, my y is equal to 2, and my z is equal to a -2. Okay? So, I'm literally going to replace the values of the variables that I see in my equations. Okay, so I'm just going to kind of write it right underneath it. My work being in purple. Looking at that first equation, I see x plus 2y minus 3z equals 9. So let's just replace, okay? What I get is -1 plus 2 times y, my y is 2, close, minus 3 times, that'll be -2, equals 9. Okay, and then going ahead and replacing those values for the variables in that second equation, what I have, is 2 times x, which is -1, and then I have a negative, and it tells me to do a y. I went ahead and put that y in parentheses because it's like I want to just know for a fact, okay, like I did plug it in, mainly because it's in the middle of the equation. And then I have a positive 2z. My z is a -2. And that equation is supposed to equal my 8. Okay, my -8. Then we have -x. Okay, so in that first equation, y'all, it was just x. It's leading. Didn't really seem necessary to put it in parentheses. I was just simply replacing that variable. In the middle, I kind of just did it for continuity, so I knew that I did replace all of them. For this third one, it is telling me a negative x. So don't look at your x being -1 and think, oh, great, it already has that negative sign, so I just write the number 1. Like, that's not true, okay? Your equation is going to be like static, right? It is what it is. It does not change. We're going to write the negative symbol, and then we're going to plug in, what it tells me my value of x is, which is -1. Of course, I can't just leave that, y'all. Super. There we go. And then just kind of moving along the rest of the equation, I have a +3 times y, I would have 2, a -4 times z, which is a -2, equals, it tells me it should be 15. Okay, so what I'm doing now is I'm actually just going to solve, right? So, I mean, anywhere on here, if you wanted to, do a little question mark, that's fine. I don't know for sure, right, if that ordered triple is a solution set for this system of equations. So technically, saying that the left-hand side equals the right-hand side, you could do an example where that ends up being false. And so, that would mean that that ordered triple is not a solution, right? So let's just go ahead and solve these. Just so as far as space is concerned, I'm just going to kind of solve them horizontally. Okay, I'm just going to move to the right. Y'all, if you look at that -1, nothing's multiplying it. I just get -1, right? Whenever you look at 2 times 2, those signs are the same. So I get a +4. When you do the -3 times the -2, well, 3 times 2 is 6. Those signs are the same, so it's positive. And then we have =9. We're still not really done with this equation yet. So let's do that second equation. You have 2 times a -1. Well, 2 times 1 is 2. Signs are different, so it's negative. And then here, y'all, you actually have, it's like an invisible 1, right? Because that 1 was there also. So what you would do is 1 times 2 is 2. Signs are different, so it's negative. And then looking at that last pair right there, I've got 2 times 2 is 4. Signs are different, so it's negative. And we're saying that this should equal a -8. And then let's do that third equation. I notice that I have, that's technically, y'all, a -1 times a -1, right? So 1 times 1 is 1. Those signs are the same, so it's a +1. Then we do 3 times 2 is 6. Signs are the same, so it's positive. 4 times 2 is 8. Signs are the same, so it's positive, right? And we're saying that this equation right here should give me 15. So still moving to the right. If you combine those 3 terms, I get a -1 and a 4. Those here, I'm just going to go ahead and do. I'm just going to do every single step, okay? 1 and 4 signs are different. So what I do is I actually subtract and I keep the sign of the larger. And then I notice that I have that +6 equals 9. We'll go ahead and finish this one. Left-hand side, 3 plus 6 is 9, right? But kind of like what I've been saying, so it makes a little bit more sense. I've been saying signs are the same, add, and we would keep those signs, and we would get 9 equals 9, which is correct, right? So now if I look at the second equation, I've got a -2, a -2, and a -4. So if you just look at those two -2s, those signs are the same. So what you do is you add them and you keep the sign. And then we have another -4. We're saying that equals a -8. Going ahead and finishing this one, I have -4, -4, right? -4 minus 4. The only thing I care about is that those signs belong to those numerical values. So that's why I can say -4, -4. Because those signs are the same, what you do is you add them and you keep the sign. And yes, it does equal a -8, right? And so now solving this third equation, I get 1 plus 6 plus 8 equals 15. Well, doing those first 2 terms together, those signs are the same. You add them, keep their sign, plus 8. I'm saying that this equals 15. Going ahead and finishing this one, 7 plus 8 is 15. And 15 does equal 15. Therefore, yes, the ordered triple -1, 2, -2 is a solution set for this system of equations. Does that make sense? Okay, so we're going to kind of change gears a little bit, of course, right? This is going to be the method that after you use pretty much everything we've learned thus far in Chapter 5 to solve a system of equations. You'll notice we're going to pull a little bit of the 5.1 into this. And when you do get to an answer, right, you get an ordered triple, in order to check your work, I know that this could seem kind of tedious, but if you had any doubts along the way, honestly, go ahead and plug in your ordered triple, right? I mean, you see all it was simple arithmetic, right? It's a combination of different signed numbers. Do you get to where you said you needed to get to? Yes, with all of them, I do. Therefore, oh, wrong button. Therefore, that means that that answer that you found is the correct answer, okay? If you doubt yourself, just plug it back in. So that's why we do that first example right there, so you know how you can check your answer. Okay, so now we're going to actually solve like a real legit problem. The directions just say solve the given system, right? So it doesn't really tell me much more than that. And what I know so far, thinking about my 5.1 work, is that I can multiply things by coefficients. I can combine things. I can, use additive inverses to cancel variables. And then after that, I can start kind of plugging that answer into an original. And then I can plug that answer into an original. Like there's all that work that we did in 5.1, right? So that's the train of thought we're going to have here. Because we're going to do work similar to 5.1, this is going to be where I label the equations 1, 2, and 3. If we create a new equation, that would be 4. Do you see what I'm saying? Like just like 5.1. So this first equation, of course, would be 1. This would be 2, and that would be 3. Looking at this, I notice that for my x's, I could, right? I'm looking for for an additive inverse, because they're all x's. If I did try to combine any of these, right, any pairs or anything, what's going to end up happening is they're just going to become 2x, right? I actually need one of them to be a negative x. So what I'm going to do, I literally chose to use the second equation, and what I'm going to do is I'm going to, how can I write this? Multiply equation 2 by negative 1, right? By a negative. Whenever I do that, that leading coefficient right there, that x, is going to then become a negative x, right? So if I combine it, right, using that addition method that we learned previously, if I combine that with equation 1, wouldn't that cancel my x's, right? So it's like I'm going to be able to solve for a variable. Also, look, too, I noticed that this is what I'm looking at, y'all. Okay, that's what I see that's similar, right? That's how I know I can work within it. I also know that if I multiply equation 2 by negative 1, it's going to turn that second term, right, that variable y, into a negative y. When I do the combination of these, the x and the y will cancel. It's going to be a lot easier to go ahead and then solve for my z. Does that make sense? So I'm still using that same train of thought, whereas I want to solve for a single variable. Once you do plug that variable into an equation, oh, wow, you just solved for another variable. Okay, now let's plug that one back into another original. Okay, you just solved for all 3 of them. Okay, so we're going to multiply 2 by negative 1. And then let me just go ahead and say, and then what we're going to do is we're going to take equation 1 and we're going to add it, because I know where I'm going here. I don't want to write that. Don't write yet, y'all, that you're going to take equation 1 and add it to equation 2, because I'm actually fixing to create a new equation, and that's going to be called equation 4. So I got a little ahead of myself there. Let's just do this first little simple step. Multiply equation 2 by negative 1. So this would look like, my work's in purple. This would look like taking a negative sign, and I'm actually going to insert right here my equation 2. Right? Do you agree with me? That's me multiplying equation 2 by a negative 1. Because there is something touching the parenthesis, that means that I'm going to distribute. And yes, you do even distribute that constant on the end, okay? And so what I end up getting is a negative x, a negative y, a negative 3z, and a negative 10. Do you notice how when you multiply something by a negative number, the only thing that technically happens is that all of the signs change, right? So this is technically going to be a new equation of mine. And that equation is going to be my 4th equation. So now what I want to do is use this equation that I just created, and I'm going to combine it with the first equation so that I can cancel. My hope is at least one variable, right? So let's go ahead and write that step. We're going to combine. I say combine because you could be doing addition, you could be doing subtraction. That's a lot of variables and a whole bunch of words. So let's just say we're combining them, right? We're going to combine equation 1 and this equation 4. So let's go ahead and write our equation 1, which is x plus y got a plus 9z equals a 34. My equation 4, I just solved it. It is a negative x, negative y, negative 3z equals a negative 10. Literally combining them. Just going to draw the line underneath. Our like terms should already be lined up. If they're not, sometimes you might have to move some things around, but more times than not, they're going to be pretty much right underneath each other, right? So if we do the combination of x and a negative x, because those are the exact same term, but they have a different sign, what we have here is an additive inverse, which means that they go away, they cancel, right? Now, if you look at my y's, I've got a positive 1 and I got a negative 1. Those also are the exact same terms, but because they have different signs, that means they cancel. So that's actually great because I was able to get rid of 2 variables. Now let's look to see what we have with our z. I've got a positive 9z, and I'm going to combine that with a negative 3z. Because those signs are different, what I do is I subtract, and I keep the sign of the larger, and that is how I get a positive 6z. Now, you also do the same thing on the right-hand side of the equal sign, okay? You've got to make sure you do the same thing to everything. And what I have here is 34 and a negative 10. Because those signs are different, what you do is you subtract and you keep the sign of the larger. Now what I would do is solve for z. I would divide both sides by 6, and I would get 4, right? And so that is what I have found to be the value of my z. So now I'm going to look back up at the original 1, 2, 3 equations, and I'm going to see what else can I do, because what I need to do, sorry, I was trying to make sure that I'm reading this correctly. If I do this, yeah. And then, okay, I just want to make sure. Okay, so what I need to do is just pretty much do the same type of steps or the same train of thought, but now my goal is to solve for the next one. I'm only pausing because I'm reading and I'm wanting to make sure my notes are right. Negative times 2 and then 1 plus 2. Oh, that's why. I went from here to here and I got confused. Okay, and then what I did next was a negative times equation 3, and then I'm going to add equation 1 and equation 3 together. And so that's also just to cancel the x, right? It doesn't work out that I can cancel the y in that time. So, okay, making sure. So what I need to do is have another equation solved for a variable. And so what I'm going to do is I'm going to look back up to the originals, and I'm going to try to see what kind of combination would work to cancel something, to get rid of something, right? So I noticed that, I actually have a couple of different options, y'all, but the one that I'm going to choose, I might even stray from my notes. I did negative times equation 3, so negative x, negative 4x, and negative 8x combined with equation 1, that's going to cancel my x. But I'm looking at this problem now, and I noticed that if I do this, okay, I would loop back around. Okay, so what I'm going to do, I'm going to actually go, we're going to be going down, but I need to make sure that we can still see our equations. I will not have the ability to cancel both variables just instantly the way I could here, because I don't have any other things that look like this where it's like, oh, you just need to make one negative. I don't have that again, right? So the steps from this point on might get a little bit more confusing, but I do know that if I make equation 3 negative, like if I multiply it by a negative and then I combine it, I add it to equation 1, I can get these to cancel, right? Because they at least do have that in common. So let's go ahead and do that. What we're going to do is we're going to multiply equation 3 by -1, and that's all I'm going to write for right now, okay? So we're going to have negative times, well, equation 3 is x plus 4y. We have a, really, like that was just nonsensical. I didn't even do anything different with my hands. Positive 4y, and then we have a positive 8y. 8z, my bad. And then we have an equal 15. Okay, so kind of didn't leave myself much room here, but distributing this -1 through everything, what I end up getting is a negative x, a negative 4y, and a negative 8z equals a negative 15. This is now what I'm going to call my equation 5. Okay, and what I want to do is take the fact that I have this negative x and I want to combine it to this negative x so that I can get them to cancel. Okay, and that's equation 1. So I'm going to, did I say combine earlier? Yeah. I'm going to combine equation 1 and equation 5. My equation 1 is x plus y plus 9z equals 34. My equation 5 is what I just solved, which is negative x, negative 4y, negative 8z equals a negative 15. Combined, just draw a line underneath them. Your like terms should already be lined up, and you're literally just going to do that math right there. If you have a positive x and you have a negative x, those are additive inverses. What happens is that they basically cancel each other, right? And if you scoot over to your y terms, what I have is a positive 1 and a negative 4. Well, those signs are different. So what you do is you subtract, keep the sign of the larger number, keep your variable, keep your exponent. If you scoot over to your z terms, what I have here is a positive 9 and a negative 8. Signs are different. So you would subtract, keep the sign of the larger, keep your variable, keep your exponent. And then I would get a 34, which is positive, and a 15, which is negative. If you do that subtraction right there, y'all, you get 19. It's a positive 19 because the largest number is positive, okay? Now let's see. Trying to think. I could actually solve. Let me see. Solve this system for 4 and 5. I could use both of these answers that I just now found. A part of me kind of wants to solve for y, but let's just go ahead and what we're going to do now. Okay, so this is, I'm trying to think of why I wouldn't want to do that. If I move that z over, I get a negative z. And then, okay, if you actually tried to solve this for y, do you see how eventually, this is not the first step, y'all, okay? But eventually I'm going to have to divide by 3. And now I've got 19 divided by 3, which is an ugly fraction. I don't want that, right? I can't easily solve this for a variable. So instead, what I'm going to do, because this is my 6th equation, I'm going to take the, if I can find it, where is it? I'm actually going to take, I already have my z equals 4. Let's take, oh, this was supposed to be a number, y'all, and I didn't number it. That's okay, though. So we'll just call it star, okay? I'm actually going to take the fact that I have solved for z, and I'm going to plug it into here so that I can solve for y, right? So that'll give me, I already have my z, now I'm solving for y. The next step would be to solve for x, okay? So what we're going to do is we are going to plug star into equation number 6. I have a negative 3y my star here is, honestly, I should have labeled that equation 5, and then this one would have been 6, and the next one would have been 7, right? But I messed up because that is an equation. It's only a, z equals y. I'm sorry, z equals 4, but it is an equation because it has an equal sign. So I'm going to plug that into equation 6. So negative 3y plus, well, my z equals 4 equals 19. Let's go ahead and solve this. I would move my 4 over, right? That would make it a negative 4. I would get a negative 3 equals, subtracting 4 over here, I actually get a 15. And then what I would do is if I would divide both sides by a negative 3, and I would get y equals a negative 5. And so that is the value for my y. Because I accidentally forgot to call this one an equation, I'm not going to call this one an equation, okay? I'll put another star next to it. Try to think of all the different math symbols we used in star's not a math symbol, but when we had multiple different things, we would start calling them different things. So we'll just this will be our asterisk. Okay, so my y is equal to negative 5. Now what I want to do, since I have a value for my y and I have a value for my z, is I want to actually plug both of those into an original. Just pick the one that looks the easiest, plug them in, you should get your x. Okay, so I'm out of room right here. My y equals negative 5. Okay, y'all. I'm actually going to move to about here. So what we're going to do, because we've solved for 2 variables, we're going to plug in y and z, plug in y and z into it's specific. It needs to be an original, okay? An original equation. Okay, so looking at my original equation, so if you look at your paper, my first one was x plus y plus 9, z equals 34. My second one was x plus y plus 3z equals 10. Honestly, smaller numbers, that looks a lot easier. Third one, I've got a coefficient with my y, so I don't want to use that one, right? So what we're going to do is we're actually going to pick equation 2 to plug these into. And so looking at equation 2, it begins with an x, which is what I'm trying to solve for. So I don't know what x is. And it says plus y. So plus y, which is negative 5. And then we have plus 3 times z, which is 4 equals 10. We're literally just going to solve this and see what we get for our x, okay? So we actually have x, that's going to be a negative 5. 3 times 4 is 12. Signs are the same, so it's positive, equals 10. I've got a 5 and a 12. Those signs are different. So what you do is you subtract and keep the sign of the larger, equals 10. Move your 7 over. I get that x equals 3. And so what I end up getting for my ordered triple is that my x is 3, my y is a negative 5, and my z is 4. Okay, sorry, it's kind of hard sometimes because there are multiple ways that you can solve these. It's just, what road do you want to go down, or can you actually see which one's the easiest? And I saw a different way other than my notes, and that's kind of why I took pause. Okay, y'all, I'm going to kind of zoom out to see where we're going here. We're going to solve this system of equations. We've got this system of equations to do. That's what I thought. That's it. So I'm going to do these other 2 examples on a different video. Okay, y'all? If you have questions, make sure you ask. Okay, thanks. Bye.